Welcome back, everybody. Let's dive into tying some of the stuff we've been doing together. And as we start to work on larger and larger SQL queries, it often becomes really valuable to break things into chunks and connect those chunks. So today we're going to go over 3 different ways to do that. Let's dive in with a sort of practical example, a new piece of syntax as well. So let's say we have a list of work orders and we want to find out which operators worked on those work orders. So maybe some work orders were entirely by one person, some by 3, 4, 5, etc. What we would do, as always, we'll select star from MES complete logs. And if we just take a quick peek, this table is going to show which operator ID worked on which work orders. Okay. So this is a great starting point. And we would typically join, let's go with MES operators, and then alias these 2 tables. So let's call this one CL, this one O, and we'll join those on CL.operatorID equals O.ID. All right, and so now we can create this very nice report with 2 columns. Maybe we just have the work order ID, and then let's have the operator name. So when I run this, we get a nice list, and let's order by work order ID. Always good to alias anytime you're using a column. So let's do cl.workorderID. And we can see right away this first work order, 4350, Susan, then Daniel, then Susan. Now, a lot of times when you're doing analysis like this, you might not want to see Susan twice. It could cause discrepancies in your data when you connect with other things. So SQL has a really easy syntax for eliminating any rows which are duplicates. So if I add this term distinct, which you may have seen before, and I run this same query, we're not going to see that row. Now this distinct is heavily connected to these column names. So for example, if I were to add cl.timestamp and run this, we're going to get that 3rd row back because this timestamp is not distinct. Okay, so when you use this distinct keyword, you have to be careful about what columns you are showing. Awesome. So we're getting this really cool list of which operators worked on which work orders, and it's unique. So we know for this first work order, there were only 2 individuals who touched it. And what you might want to do from here is maybe count and start to understand which work orders had 5 different operators, or which work orders maybe had 1 work order only. And there's a ton of ways that we can start to use this query right here the same way as we use a table. Again, remember that SQL is just a language for transforming 2-dimensional data tables. And the output of that first query is a 2-dimensional data table. So I'm going to show 3 ways we can do this. The first is just natively in hex, which I think is pretty cool. So you'll see down here at the bottom that we can write this table. In fact, it automatically writes it to something called data frame. Let's go ahead and rename this, and we will call it unique operators by work order. Anything you'd like. And what's really cool about hex is that when we run this and we then write a query that says, maybe just to start, select star from unique operators by work order, hex is going to run every set of notes or every set of cells that are dependent on each other. So when I hit this run all button in the top, it's going to first run this first query, and it's going to write that to unique operators by work order. Then when I'm selecting star, let's find out what I did wrong. I forgot a word here, very important. And so now you can run all your cells, and it's going to go through the logic and make sure that it runs this one before it runs this one. And so now we're basically working on our own custom table and we can start to apply any logic we would on a regular table. So what I want to do now is get a count of how many operators worked on each work order. So very simply, building on the aggregations topic, we can do select work order ID, and then we're going to count the operator name, or realistically, we could count even star, right? Because we're just counting the number of rows. So using this star, using 1, using even work order ID, it's going to return one record or one count per record, okay? And then the only thing to do whenever you aggregate is to make sure that you use the work order ID. And so this should work as anticipated. And what you start to form is these really nice, clean tables that are easier to read, understand, and share with others. So let's give this a proper name, distinct operators. We'll just go with that. And then I'm going to use that as my order by. And so now, if someone was curious, we could look for this work order in particular, which only had one operator, or I could go in the other direction and see all of the work orders in which 5 different operators performed on that work order. So really cool way to think about segmenting your logic as you start to write more complex queries. Now, this way that I just showed is inside of hex, right? So this would only work in hex. But if you're using another database tool, or if you're just hitting SQL directly, there's 2 other ways you can connect logic. So I'll do the first, and I'm actually going to copy first this table, okay? Rather than reinventing the wheel, I'm just going to show the syntax for how SQL performs subqueries. Okay, so this table we want to replace with a subquery. So let's do this, and let's put some space in here. And as you might expect, SQL allows you to take queries and use them inside of one another. So I'm going to wrap this in parentheses. Good syntax, you might indent this. Everybody does it a different way, so whatever works for you. And now when I run this query, SQL is going to go inside out. So it's actually running this and then taking the data from that query and running the outer query with this as the inner table. So we're getting the exact same results, but this time only with one subquery. Now, this syntax in this case is not too bad, but as things start to get more complicated, or for example, if you needed to use the same inner table twice, this is sort of the frowned upon way to perform longer SQL queries. The more refined and programmatic way to have 2 queries in one SQL query looks a little bit something like this. So I'm going to pull this down, and here we're going to be using what's called a common table expression, or a CTE, and your syntax will look a little bit like this. So you're going to write with this, so you're saying with this table as, and I forget what I called it earlier, so let's copy unique operators by work order. Okay, so let's take the subquery here, which I think I already had copied, and we can put that just like before in this little CTE. Okay, and then the same as before, we can now reference that table directly in a query. So now this example looks a lot like the first one that I showed using hex, and you can see why this is much cleaner to read and work with. And there are definitely scenarios where you might actually need to interjoin a CTE to itself. So in that case, you would not need to write this CTE twice. It can be useful for both readability and optimization reasons. But if I did everything correct, you'll see that now when I run this, this is always good to go through some error messages. So with this as, there's a syntax error. So usually when you see a syntax error, you want to go back and look at your query and think about maybe what you did wrong. And now I think I'm mixing up my ordering for this syntax. And I think I was supposed to do this. So ignore what I just showed, and I believe the proper syntax looks like this. So good lesson. Make sure you get your syntax right, but the ideas are still the same. We're able to write this query up top. We go with table name as, open up a parentheses, write your subquery, and then you can do your second query as if that subquery was already a table in the database. So as always, let's dive into some practice problems just to really work on our joins, work on everything we've been learning so far, and apply these new skills, okay? So which operations had the most quantity scrapped? The reason this problem might be a little tricky, if you look at the MES scrap logs table, we're going to see the operation ID is not in this table. So what you'll need to do is create a subquery or a CTE or an extra query. Go ahead and try any of the above approaches and create one query that connects the resource ID to the operation ID. Again, all resources are within an operation. And then from that subquery, create a final query which sums the quantity scrapped for each operation. Pause now. All right, let's get started. I'm first going to just go through the subquery part, and I'm going to be using the CTE approach. So I'll practice just by selecting star from MES resources. I'll call that R. And let's inner join MES operations O on R.operation ID equals O.id. Again, if you're struggling to follow along with these joins, I recommend you go back to the previous maybe 3 videos ago where we started doing joins, and keep going through the videos. We use them in each episode to really dive into these practice problems on this data set. Okay, so when I run this, I'm pretty confident that I can now get R.id and O.operation name. And we should see a long list here. Now, it's always good to rename these ID columns. You want to be more specific, so let's call that RID as resource ID, and maybe clean some things up. And so this is going to be our subquery that we can use to connect a resource ID to the actual operation name, okay? And so we can do with resource operation lookup as, I'm going to open this up, and I'm going to create this CTE by just wrapping it in parentheses. And then now what I can do is, with my lower query, again, just select star from to get started, and I want to look at those scrap logs, MES scrap logs, we'll call that SL, and we can now join to our CTE. So if I paste this in, and we'll call this ROL. Again, this is being used just like a table that already exists. And I'm going to join on ROL.resourceID. Notice that the alias from the CTE applies when you're joining to that table or when you're pulling columns from that table. and we're going to find where SL, or that is equal to SL dot resource ID. Okay, let's clean this up. And so now if we run this, we should get a long set of all the values that we need, and including the operation name. Okay, so all we have left to do is select the columns that we're interested in. In this case, let's pull the the ROL dot operation name, and let's sum the quantity from the scrap log table. So if we sum, and we'll call this total scrap. Again, anytime we're aggregating, we have to remember the group by clause. SQL will give you an error if you forget, so this is always a very common syntax error that you'll come across. So let's group by ROL dot operation name, and let's finally order by total scrap descending, and we should now see the order of which operations had the most scrap. So unsurprising, the inspection station is where we lose the most material. There are people looking at the product and getting rid of anything that looks defective. And the mixing station comes in second, unsurprising because it's the first operation in any process. So it's always going to start with the highest quantity.